Hi, welcome back to the channel. Hope all your deployments have been great this week, and today we're going to be talking about infrastructure as code. Infrastructure as code. What is infrastructure as code? The benefits of infrastructure as code, the tools, the helpful programs that can enable you to handle that sort of thing, and then managing it and handling it. So let's get into it. What does it mean to you? Infrastructure as code, I'm sure you've heard of it. Let me know in the comments. To me, infrastructure as code is storing your configuration as code that can be tested, deployed, and maintained, all in a repeatable way. We want our infrastructure to be in such a way that we can repeatedly install it and deploy it as many times as we need to, tear it down, set it up again. Heck, some people get development environments and they tear the whole lot down on a Friday because there's no point paying for it. If you're using a cloud provider, why would you pay for something you're not going to use for Saturday and Sunday? That's one way that cloud providers can be cheaper than running your own data center. Come Monday morning, have an automated process that then creates your infrastructure from scratch again. How can we do this? Well, it's because all the infrastructure is defined in code. And once we've defined something in code, it means we can test it, either statically or by actually running some real tests against it, and deploy it multiple times, again and again. Why does this matter? Well, if it's repeatable, it means it's less effort for us to do things. Are you going to be afraid that your server fails, dies, or just delete it? Not if you've got everything backed up. Keep the data safe, keep the configuration safe, and you can restore everything to exactly as it was before. So when I talk about infrastructure, what the heck do I mean? I'm talking about servers, networks, the rules governing access and security around those servers and networks, where the logging goes, how about the application configuration, what sort of things your application needs in order for it to run, name of the environment, name of the subnet, heck, even the definition of the subnet. So we've got servers where the code can run. We can tell the code that it's scalable. What's the minimum number that we need to be running? Is it 1? Is it 2? Is it 3? And what's the maximum that we want to spend on our infrastructure for it to scale up? Make it scalable. When we're scaling down, we're going to lose any data on those servers. Where do we need to back that data up to? Most of the time we're just after the logs. After all, we're not editing code on our live servers, are we? We're just keeping those logs and that monitoring stuff that I spoke about in my last video. Store those logs somewhere safe and we can destroy the server. Easy peasy. And the networking is important. Servers need to survive in a network. They're pretty useless if they're not talking to anybody else. So what does the code look like? I said infrastructure as code, we've covered the infrastructure, and now we're on to the code. Well, some tools come with their own language, like HashiCorp, and other tools just use YAML. It depends on the tool that you're using. So let's talk about the tools. We got Terraform, Ansible, and stuff to run the pipelines, like a Jenkins server. So first up, Terraform. What does that do? It uses HashiCorp configuration language, and it can go cross-cloud with multiple providers and modules. Providers are a way of expanding the core Terraform into having other functions that can be used with an upstream API. When I talk about an upstream API, I could be talking about something like AWS, or Google Cloud, or Azure. They have application programmable interfaces that we can write a program in order to then manipulate stuff within those environments. The program in this case will be the Terraform provider. So there's an AWS Terraform provider that talks to the AWS API. So by using Terraform, talking to the Terraform provider, it can then talk to the AWS API and provide and destroy resources that are provided by AWS. Similarly, if we had a cloud provider that was defined, say, Google, so we've got the Google Terraform provider can then talk to the Google Upstream API and control the Google resources. And there's many providers available to Terraform, from stuff like controlling hardware to even software providers. There's a JFrog Artifactory provider where you can talk to your locally installed Artifactory API and configure it through code by using Terraform. Okay, so we've got Terraform, we've got our provider, and so it knows how to talk to the API, but what is it actually going to tell the API? Well, these are then defined in modules. Now, you don't have to use modules. You can just use one massive lump of code at the top with a main file and outputs and the variables. Heck, you don't even need to split it into these 3 files. But if you don't, it's going to be really unmanageable. Most configurations I see, you'll have a main TF with some outputs and some variables. And that will then define what modules it wants to pull in. Each one of those modules in turn has a main file, outputs and variables, so that you can tell each module what you want to know. It can then do it in the main file, and then it can report back to you what it's done in its outputs. Now, Terraform allows for a lot of flexibility. You don't have to have these 3 file names. Like I said, you can have just one big file. In fact, when it runs it, that's exactly what it does. It concatenates all the TF files together and then just runs it as one file. But for us humans to look after it, it's better if we name it something sensible. So if you're talking about a module that has some infrastructure component and some security or access component, you might want to split those out into separate files. So moving on to our next tool that's often used with infrastructure as code, and that is Ansible. Ansible does something slightly different to Terraform. It's configuration management. It also uses YAML to record its information and configuration. And it also has a kind of modules, except in Ansible they're called roles. Now, role structure also has its own thing, and again, this is best practice, just to separate things out so you can understand what's going on. At the bare minimum, it will just have a main.yaml. The main.yaml has to exist. It's what Ansible looks for in a role. But you can expand it by having separate other YAML files which will have other detailed stuff in. Like the example here, we've got our main YAML, then inside the main YAML it will detect if the operating system that it's running on is CentOS or not, CentOS or Debian. And then depending on what it finds out, it will then include either the Debian file or the CentOS file. Most roles are set out in a similar way so that they're cross-compatible with multiple operating systems. Each role will have a given goal of what it wants to achieve. So it might be managing a Jenkins deployment, or it might be managing a web server, or something like that. You can then put multiple roles together into one host configuration, and then you point it at that one host. The host then says, okay, I'm a Jenkins server and I'm whatever else it needs, and I'm going to run those roles. Using Jenkins as an example, you might have a role that says, I need to be a server capable of running Jenkins. No kidding. But Jenkins has dependencies, so you might also say as a role, I'm a server that's capable of running Java. So how do we manage these things? Well, because it's code, we can use our normal code tools to manage these things, such as Git. And if it's in Git, it means we can also execute it in pipelines for our CI/CD server. Ironically, you can set up a Jenkins server using another Jenkins server. Probably not the best idea, and this way you get the Jenkins chicken and egg, but I'm going off track here. Once we've got the code, we can then version control it, manage it, share it, and run it as we see fit. Of course, if it's a CI/CD pipeline, we can also test it using testing tools available to us in Terraform, and testing tools available to us in Ansible. If you're enjoying this video, then I'd like you to like the video and subscribe if you want more content like this. So in summary then, we've got HTTP Terraform, it's HashiCorp to you and I. It can run infrastructure as code that we can store in our Git repository and then run it through any pipeline system like GitHub Actions or GitLab or Jenkins. In turn, this will then create a remote state file, which we need to keep safe. And this is so that Terraform can tell what's changed and what hasn't changed. Then Terraform, through its providers, can talk to whatever API it needs to talk to. Perhaps that's GitHub, or AWS, or Azure, or Google Cloud. And we can run this code over and over again to make sure that everything stays up to date. Or, in the event of scaling down, we can run our init, our verify, our plan, our apply, and then when we get to Friday, run a destroy. Get back to Monday and do it all over again. Then Ansible comes along and helps us with those servers. We've used Terraform to create our network and our servers, and we need something to configure their servers so that they know what roles they're going to do. And so by using Ansible, adding to an inventory is a list of hosts and the roles that they have, put those together in a playbook, which then means that the Ansible server can use the playbook to assign certain roles to certain servers in our inventory. And with that, once Terraform has created those servers, Ansible comes along and configures the servers so that they're ready for work. Now, this is not the only tools available that do these jobs. If you're dealing with infrastructure and you don't need to go cross-cloud, then perhaps you want to define stuff in CloudFormation directly if you're using AWS. Or Azure or Google Cloud both have managers too. In configuration management, you don't just have to use Ansible. You can use something like Chef or Puppet, which are closely related, or go a bit left field with SaltStack. I hope this has been useful to you, and if you've got any questions, put them in the comments below, and I'll answer them as best I can. Until next time, may all your deployments be smooth.